comes to electric cars, Toyota has caused quite a stir. A possible game changer, according to the CEO, their most recent engine is creating quite a stir. Envision a motor so incredible, it baffles even the most seasoned auto enthusiasts. Contrary to what other automakers are doing, Toyota's new engine operates on hydrogen. They're really doing something new. And here's the kicker. It just releases water rather than toxic gases. That is a remarkable demonstration of Toyota's dedication to promoting environmental sustainability. It's a revolutionary, mind-blowing development, not just a significant one. So let's take a closer look at the engine. In an innovative move, Toyota has introduced the hydrogen combustion engine as a means to address environmental concerns. Given its cosmic abundance, hydrogen has the highest specific energy density of all non-nuclear power sources. Besides water, it doesn't discharge any exhaust when used as fuel and doesn't generate any toxic byproducts. Taken together, Toyota's groundbreaking engine offers a fresh perspective on electric car technology and a plan to reduce human activity's environmental effect in the long run. Its composition allows for easy transportation, extended storage life, and mass production from a variety of resources. There aren't any issues with producing or using millions of tons of hydrogen every year. I bet you didn't know that. This is obviously not some obscure concept. It powers electric rides, buildings, ships, trucks, and trains. These days, you don't always need gas. Are you acquainted with the Toyota hydrogen combustion engine? It's an ingenious gadget that turns hydrogen into electricity using a fuel cell. The Toyota Corolla Cross H2 is one example of a concept car. Its 1.6-liter turbocharged three-cylinder engine is the only component of its hydrogen powertrain. But what was it that gave Toyota the advantage? Because of this, they resolved to utilize these groundbreaking engines to radically alter the electric vehicle market. A sea change was about to occur in the electric car industry. Their hidden plan will be revealed soon, so be sure to stay tuned. This secret sauce of Toyota's is the highly flammable hydrogen fuel housed in these heavily reinforced fuel tanks. The idea was based on the Mirai, their FCEV, but it makes no difference how big these tanks are. The Corolla Cross H2 concept car can go around 300 kilometers on a single tank of 5 kilograms of hydrogen. And what's going to happen to the leftovers? It's only 50 gallons of water. My most recent evaluation has it that water, in contrast to carbon dioxide, isn't exactly detrimental to the ecosystem. The icing on the cake is a V8 engine that runs only on hydrogen, which was developed in collaboration with Toyota and Yamaha Motor. Well, isn't this cool? Impressive power and torque output from this engine, 455 horsepower and 398 lb-ft, respectively. What makes it stand out is the distinctive high-frequency sound that is produced by an 8-one exhaust manifold installed on top. The Toyota Prius stands out from the crowd of electric vehicles thanks to its hydrogen combustion engine and a host of other advantages. Some of its most impressive characteristics include an incredible range and a refilling pace that rivals that of a drag race. Because of this, less of the scarce materials like nickel and lithium that are needed to make batteries for electric vehicles is required. It stores energy in a battery that isn't as cumbersome as those in electric cars. Late in 2023, the Corolla Cross H2 prototype was being tested in real-world settings, including as the snowy roads of northern Japan. So far, the response has been really favorable. All things considered, the automobile industry has undergone a sea change due to Toyota's revolutionary hydrogen combustion engine. As a result of producing just water, it is considered one of the most eco-friendly engines. It also has less reliance on precious resources, a shorter refueling time, and a longer range. It will be a while before we see these vehicles on the roads, but we are anxiously anticipating the outcomes of real-world testing. Just 1 year from now, in 2025, the Japanese government hopes to have around 200,000 fuel cell automobiles on the road, predicated on the success of the hydrogen-powered engine. By 2030, they want to have reached 800,000. The development of filling stations around the country is obviously going to be required to accomplish this aim. We can attest from personal experience that there is no engine on the market like the hydrogen combustion engine. However, are its benefits and drawbacks being considered? The good news is that we can start with that. To start with, and maybe most importantly, it's a very environmentally friendly choice. It uses hydrogen as its fuel source, thus it doesn't make any toxic waste. When contrasted with conventional gasoline engines, hydrogen fuel is inherently cleaner. Second, the cooling system of this engine is quite efficient. The novel water cooling technique addresses a significant issue that engines face: excessive heat. This characteristic is already present in hydrogen combustion engines, and it might greatly improve performance and longevity by lowering the frequency of problems like overheating. Without a doubt, this would greatly benefit drivers in real-world scenarios. Thirdly, you're probably already aware with the technologies that this engine uses. Its ability to function similarly to conventional engines facilitates its incorporation into pre-existing procedures for the design and production of automobiles. The fact that Toyota can readily modify this engine to fit into many of their current car models is a huge boon to the company. There are a number of obvious advantages to this engine. Still, downsides exist, as they do with everything. The main drawback is the infrastructure and manufacturing needed for hydrogen. The production method of hydrogen determines the engine's environmental effect, which is already very low impact. Despite the extensive production of hydrogen, it is not always sustainable at the moment. Therefore, Toyota must resolve this problem prior to mass producing these vehicles. Hydrogen is readily available, however, refueling infrastructure is inadequate, particularly in comparison to that of gasoline and electric charging stations. The complexity and high expense of hydrogen combustion engines are further obstacles. The dual water injection system and the need for precise management by the Engine Control Unit, ECU, make the arrangement more difficult, even though they share a fundamental design with other engines. As a result of the increasing complexity, production costs for Toyota go up, and maintenance costs for customers go up, since components are more difficult to come by. So, let's pretend Toyota plans to make a lot of these engines. If that's the case, taking their time and being cautious are necessities. The problem of being ready for the market must still be addressed. We are now in the process of testing and refining the final version of this design. Although the automobile may be approved for release to the market, it will still be quite some time before it reaches the commercial market. The development of this hydrogen combustion engine is just one more example of Toyota's commitment to investigating environmentally friendly modes of transportation, in addition to its hybrid and electric vehicles. Their dedication to provide more environmentally friendly car alternatives is shown by this revolutionary hydrogen combustion engine. There has been much discussion on combustion engines and how they may affect the EV market. My question is, how? How does an engine that runs on hydrogen compare to a conventional internal combustion engine? What distinguishing technological aspects make it stand out? As an example, let's take a closer look at the 1.6 L3-cylinder turbo engine, which is one of Toyota's outstanding achievements in this field. You may be asking why we're focusing on this specific engine. This is due to the fact that it is among the most popular hydrogen engines produced by Toyota. At this very moment, it is providing outstanding performance to the Corolla Cross hydrogen prototype. This engine does an excellent job of blending traditional styling with modern technology, but it's really different from the conventional internal combustion engine. An engineering miracle is the 1.6 L3-cylinder turbo engine. The GR Yaris, a Toyota vehicle renowned for its exceptional performance and agility, served as the basis for this engine's development. Nevertheless, substantial adjustments were required to convert the engine for use with hydrogen fuel. In the aftermath of these changes, many were wondering how Toyota kept the engine's performance intact despite switching to a whole new fuel. How hydrogen is burned provides the solution. Hydrogen, in contrast to gasoline, requires different combustion and handling procedures. In response, the engine ditches the traditional fuel injection process in favor of a high-pressure hydrogen direct injection technology. This method improves performance and efficiency by accurately controlling the supply of hydrogen into the combustion chamber. What effect, if any, does this have on the engine's overall performance? The outcomes might take you by surprise. The 1.6L engine can still produce as much power and torque as its gasoline-powered equivalents, even if it has switched to hydrogen fuel. The turbocharger is largely responsible for this success, since it provides the essential boost for great performance. Yet others have questioned whether turbocharging is the best way to take use of hydrogen's certain qualities. The primary worry is that, because to its lower density, more hydrogen will be required to generate the same amount of energy as gasoline. Technical staff at Toyota have studied the issue thoroughly and made adjustments to the engine's turbocharger and other components so that they can take advantage of hydrogen's unique characteristics. This engine is defined by its extraordinary efficiency. Hydrogen combustion engines outperform their conventional counterparts under heavy loads while also being more environmentally friendly and economical. This enhanced efficiency results in much decreased emissions, better fuel economy, with the only byproduct being water vapor. Since it generates almost no emissions, it is very eco-friendly. Toyota's commitment to achieving carbon neutrality and their aim of almost zero emissions are in sync with each other. Toyota has used a multi-pronged approach, integrating electric and hydrogen technologies to achieve its goal of a future without carbon emissions. They should have played it safe and highlighted their state-of-the-art technology, but instead, they're taking a risk. Why? We need to achieve carbon neutrality in the most comprehensive and significant way possible. Getting there isn't enough. We can better comprehend Toyota's thinking if we look at their unwavering dedication to hydrogen technology. But you may be wondering, why is hydrogen the superior choice? The potential it has as an incredibly clean energy source is what ultimately determines its fate. Fuel cells and internal combustion engines that employ hydrogen produce only water vapor as a byproduct. Here we have a long-term solution that can replace fossil fuels. Yet, Toyota's excitement for hydrogen goes beyond only cars. Additionally, this technology has been used by commercial vehicles and public transportation systems. However, it is still unclear whether hydrogen alone can bring about carbon neutrality. A lot of consideration has gone into this, since Toyota is aware they can't rely on a single technology. They have also started driving electric vehicles for the same reason. On the other hand, Toyota isn't following the lead of other car companies who are putting all of their eggs in the electric vehicle basket. A more eclectic approach has been taken by them instead. They have now come to terms with the truth that electric vehicles aren't perfect. Some of the issues include a lack of range, lengthy charging times, and the environmental impact of battery production and disposal. Toyota has many solutions for electric vehicle powertrains, including hydrogen fuel cell automobiles, plug-in hybrids, and battery electric vehicles, BEVs. With this move, Toyota intends to meet the needs of a wider range of customers and road conditions. This all-encompassing approach aims to achieve carbon neutrality. However, Toyota has addressed this issue via several means. They have learnt, among other things, that environmental laws, energy supplies, and infrastructure differ substantially among regions and markets. Hence, a one-size-fits-all strategy may not be the way to go if we want to reduce carbon emissions on a global basis. Where renewable energy sources are abundant, battery electric vehicles, BEVs, are the preferred mode of transportation. In areas where the production of hydrogen is reliant on renewable energy sources like solar or wind power, fuel cell electric vehicles, FCEVs, and hydrogen internal combustion engine vehicles, HYCEVs, could be the best choice. Beyond the emissions of its automobiles, however, Toyota's dedication to attaining carbon neutrality extends far. To lessen the toll that their manufacturing processes have on the environment, they are exerting every effort possible. Included in this are efforts to recycle, save resources, and finance renewable energy projects. They still have a ways to go before they accomplish their ambitious goal of becoming carbon neutral. In order to comprehend Toyota's strategy, we must have a bird's-eye view. In order for our society to achieve carbon neutrality, there must be significant changes in both the energy and transportation sectors. Using a variety of technologies in tandem with environmental initiatives, Toyota is attempting to tackle these concerns head-on with its approach. There are significant environmental advantages to become carbon neutral, but that's not all Toyota's initiative does. It will be helpful to step back and examine these benefits in more detail so that we can grasp them. As the automotive industry continues its transition towards sustainable energy, the possibility of hydrogen-powered internal combustion engines being used by Toyota is intriguing. What about hybrid electric vehicles, HEVs, and plug-in hybrid electric vehicles, PHEVs? And how do they compare to these hydrogen engines? We can examine the distinctive features of hydrogen engines and their impact on the environment to address your issue. It is vital to consider their emission profile. Conventional gasoline engines emit obviously high amounts of carbon dioxide, a potent greenhouse gas that significantly adds to the problem of climate change. Conversely, Toyota asserts that its hydrogen engines do not emit any CO2. It is entirely feasible to get zero carbon emissions, just in case you were curious. When it comes to the combustion process, hydrogen engines really excel. By interacting with oxygen in the air, hydrogen fuel combustion releases energy. To keep things simple chemically, this reaction merely produces water vapor, H2O. A significant step towards reducing the environmental impact of the automotive sector may be shown by eliminating carbon dioxide from exhaust pipes. To what extent, therefore, are HEVs and PHEVs similar and distinct? Hybrid electric vehicles, HEVs, have a different set of controls since they blend gas and electric motors. On the other hand, plug-in hybrid electric vehicles, PHEVs, may have their batteries topped up. The engines still use gasoline, thus they still emit some carbon dioxide, although less than previously. Nonetheless, they boast of being more fuel efficient and producing fewer pollution than traditional gasoline-powered automobiles. However, if the hydrogen fuel can be supplied in an environmentally friendly way, hydrogen engines might be the key to truly emission-free transportation. Another aspect to look about when considering these vehicles' impact on the environment is the cumulative emissions they emit during their lifespan. A big concern with hybrid electric vehicles, HEVs, and HEV batteries that use rare earth elements is the carbon emissions that result from energy-intensive manufacturing procedures. Regardless, hydrogen engines have managed to sidestep a number of these issues. It is possible that producing hydrogen fuel, particularly when fueled by renewable energy sources such as solar or wind, would be more environmentally friendly than manufacturing batteries. It has also been shown that hydrogen combustion engines are far more efficient than traditional combustion engines. This becomes very important in situations when engines and hydrogen fuel cells are equally efficient, such in heavy-duty applications. Fuel cells perform well under light loads, but their efficiency starts to drop as the load becomes more. However, hydrogen combustion engines shine when subjected to substantial loads, making them ideal for use in demanding environments. Hydrogen engines, developed by Toyota, put cleaner, more sustainable transportation within reach without sacrificing performance or practicality. Climate change and the depletion of natural resources are constant enemies. All right, let's talk about its effectiveness now. Now that we know hydrogen engines can hold their own against gasoline ones, the question is, how exactly? The qualities of hydrogen as a fuel are crucial. The burner for hydrogen is faster than that of gasoline. This quicker combustion leads to enhanced responsiveness, which is an essential part of high-performance driving. But how does this affect the overall driving experience? Drivers look forward to the performance, rapid throttle response, and robust engine noise that come with traditional internal combustion engines. The feeling is familiar, like the rumble of a Dodge Charger's engine starting up. Intriguingly, hybrid electric vehicles, HEVs, retain all the features of regular cars while using a clean fuel such as hydrogen. Those who drive Toyotas fueled by hydrogen may enjoy the same ride quality. Not only does it have powerful performance, but it also has the engine sound that many car enthusiasts love. The question is, can they match the efficiency of more conventional engines? Toyota has tested this in the extreme racing environment. They were able to show the fuel's potential for great performance and its extended lifetime by entering a racing vehicle fueled by hydrogen. Even in these harsh environments, hybrid electric cars have shown to be just as fast, nimble, and durable as their traditional counterparts.